Hello.
Hi, Matthew.
Hello.
How are you doing tonight?
Good. This right here is some extra credit for the test because everyone didn't do so good, so she figured she needed to help us out.
Okay. Let's take a look at this. If your hospital day 1 assignment is incomplete, huh? How's your teacher pronounce that? Lahopital?
Yeah, L'Hopital is a rule.
Lopital?
Yep.
Not 2 syllables like I just did. Okay. Let's see, a squirrel starting at building A. Where's building A? I don't see a building A in that diagram. Am I missing something?
At time, maybe time 0.
Oh, okay. All right. I got it. Travels along a straight wire connected to building B. The squirrel's velocity is modeled by the piecewise linear function defined by the graph above. Okay. At what times in the interval, 0 to 18, if any, does the squirrel change direction? Give a reason for your answers. Why is it 9 and 15?
Because velocity changes signs.
Yeah, it stops. In other words, if this is the velocity curve, then his velocity is 0 right there. And he's going from a positive velocity to a negative velocity. You can't do that without stopping first. But actually, right there, even if it didn't change signs, even if it came down to that line and went straight back up, that would still mean he was stopped.
Well, yeah, but don't we want to do that one?
Oh, they only want to change directions. Okay, sorry. Yeah.
That's fine.
Okay, at what time in the interval is the squirrel furthest from building A? Well, furthest away from building A means maximum displacement, right?
Mm-hmm.
Maximum displacement is the area under the curve. In other words, he's going to the right, increasing velocity, still going to the right at a constant velocity, still going to right at a decreasing velocity. So once he gets right there, he's as far away from that building as he's getting, because now in this part, he's going back the other direction. He's going to the left, still going to the left, still going to the left. And the question is the area under this part of the curve right here exceed all of the area that he went to the left? And no, it does not. So he never gets as far away from the building as at that point right there at 9.
So how to make a table? Because I know the point. It's obvious, but she says distance is 140, and then she says make a table.
Okay. Well, the distance is the area under that curve. That's a trapezoid. I'm not sure why we need a table. All we need is the area of a trapezoid. One base is 9, the other base is 5. The average base is 7, and the height is 20. That's 140 is the area of that trapezoid. Not sure what she wants from the table. In other words, from a calculus perspective, that distance is going to be the integral of that function from here to here.
So from 0 to 8, the integral of, it doesn't have a function.
Well, we see the function, but the concept of the integral of a function being the area under the curve is the important concept to get. In other words, if I knew what this function was, had she given it to us, then I would merely integrate it from 0 to 9. But that's the same thing as finding the area under that curve. We don't need calculus for that because they've made this a geometric shape. We don't have any curved lines. You only need calculus when you're dealing with curved lines, basically. Otherwise, you can use geometry. So I'm not quite sure what table she wants you to make. I don't know. But what could that table be?
Maybe comparing the areas under the things.
Maybe she wants you to say that at time 2, you've gone the distance of the area of that little triangle. And then at time 7, you've gone the distance of the rectangle, more. And then the area of this little triangle. I don't know. I'm not really sure, to be honest. And I don't quite see how it's going to be helpful besides.
Yeah.
In other words, the concept is knowing that the area under that curve is the displacement. And in fact, the net displacement from here to here is the net area under the curve. In other words, this area minus this area plus this area. That would be the total net displacement. And it's not going to be 140. That's the maximum displacement you get right there. All right, let's see. C, find the total distance the squirrel travels from 0 to 18. Well, it would be the positive area there, which we know is 140. And then this is the distance in the other direction, but it's still that if we took the absolute value of this function and integrated it, we would get the total distance traveled. If you integrate a velocity function as is, you get displacement. Now, you understand the difference between displacement and distance traveled?
Yep. I think.
That's a lot of distance. Well, here's a number line. Here's our starting point. If we go that way and back to that way, we've traveled that distance twice. So the distance is twice. The displacement is 0. We're back to the same starting point. What's usually going on in these situations is, I'll draw it as a parametric curve. You go that way, and then you go back that way, and then you go back that way, and then you go back that way. And so what they want to know where you end up, well, the distance from there to there is the displacement. The total distance traveled, one all the way back, all the way back, all the way back, is the total distance traveled. So from here to here, displacement and distance traveled is the same. It's 140. The squirrel starts right off going one direction for 140 feet. Okay, then it goes the other direction. So the total distance traveled in the other direction is the area of this trapezoid. What is the area of that trapezoid? It's 4 is the base, 9 to 15 is 6, the average base is 5 times 10, 50. So it goes 50 feet back the other way, but the total distance traveled from here to there is 140 plus 50. And then the final 140 plus 50 is 190. The final 25 is in this direction, back to the right. And that, again, is a trapezoid of average base. let's see, it goes from 15 to 18, so that's 3 and 2. The average base is 2.5 times 10. There's your 25 added to the 190 gives us 215.
Should there be units, or does it not? Since it doesn't give us units, we don't like to make them up.
Doesn't seem to give us units, but these are obviously, this is a rate chart, so this is either a feet per second or a feet per minute. So all of these answers are in the linear feet or meters, whatever it is.
Mm-hmm.
All right. Write the expression for the squirrel's acceleration, velocity, and distance from building A that are valid for the time from 7 to 10. This is all for you. We got to figure this one out ourselves, huh?
Mm-hmm.
That's funny. Well, what is the acceleration?
Isn't it the derivative of velocity?
Yeah. So, and derivative is slope of the curve, right?
Uh-huh.
So, what is the slope of the curve from 7 to 10?
7 to 10 would be over 20.
Down 30 over 3. Minus 10 would be the slope of that.
Oh, yeah.
So during the entire time from 7 seconds to 10 seconds, the acceleration is minus 10. Minus 10 feet per second per second. He's slowing down considerably.
Should I say feet per second or not? Because we don't get.
Yeah, well, you can certainly say per second, although they don't even say seconds in here, do they?
They don't give us anything.
What's that?
They don't give us any sort of.
No, then don't say any units then. I mean, you can't put down a false unit. I guess you could say distance per time squared. Yeah, you could say minus 10 meters or feet per second squared or per minute squared, depending on what the units are on the problem, which were never given to you. So the expression for the squirrel's acceleration is rather straightforward. It's a constant. A of t is equal to minus 10. That's the expression for the acceleration in that
Would
time.
it be capital or lowercase?
Lowercase. I don't think there's a, yeah, there probably is a convention. I don't know why I used capital there. Now let's talk about the expression for the velocity. Well, what's that going to be?
Would it be, we would just do the antiderivative of negative 10?
Yeah. Minus 10t. Well, I think that's the answer. I'm not sure whether we need to add a c on that or not. I don't think so. No, the velocity is minus 10t. In other words, the velocity at this point was minus, or excuse me, the velocity was 70 units per second, and at, hold on a second. How is that this function? Oh yeah. If I ask you to define that line, you would say y equals the slope minus 10t, and there is a c. In this case, if they want the velocity as an equation of that line, then we need a y-intercept. Or an x-intercept. And we know that, let's see, if I say y equals, let's see, if I got y equals minus 10t plus some y-intercept, plus b, and I know that at time equal 9, y is 0, so now I can say 0 equals minus 90 plus b. b is equal to 90. So the equation of the velocity line between 7 and 10 is y equals minus 10 plus 90. That's the expression of that line.
Y equals minus 10t plus 90?
Yes, sorry. I left out the variable. Yeah. Okay. Now, the last thing they wanted was the distance. The acceleration and distance from building A. Okay. So the distance from building A from 7 to 10 is the area of that triangle minus the area of that triangle. In other words, if I make that 7 and I make this 10, the distance traveled at this point at 9 seconds is going to be the area of that triangle, but this distance here is in the other direction, back towards building A. So I have to subtract out this distance, this area, from that area. So an expression, I presume they want it as a function of t. Well, let's see. If we integrate that velocity function, what do we get? We get minus 5t squared plus 90t plus some c. And that would equal one second, I'm thinking. That equals the displacement. So I can solve for c by substituting 9 for t. I know my displacement was 140 at 9 seconds. So let's see what happens here. So let's see, minus 5 times 81 plus 810. Now let's see, that's 10 times 81, that's minus 5 times 81, that must be a plus 5 times 81. If I move it over to the other side, I get a negative, I get 140 minus 405. I think I'm doing this right. That's minus 265 equals C. So for displacement, that's not what they asked for, though. They asked for distance. In other words, that would be minus 5t squared plus 90t minus 265 would be an expression for the displacement. Distance. We want the integral of the absolute value. That's what we want. We want the integral of the absolute value of this function. What was that, plus 90?
Mm-hmm.
And that is distance. In other words, if you knew the function, if you could put the function into your calculator, the distance traveled from 0 to 18 is the integral of the absolute value of this function, meaning the positive area here, well, this would come out as negative area, but if we made it absolute value, it becomes positive. In other words, I draw this on the other side of the x-axis if I'm taking the absolute value of that.
Wait, on that integral, should I do the integral from 7 to 10?
Yes, because that interval from 7 to 10 includes both directions. It's going to the right, and it's also going to the left.
Mm-hmm.
So displacement and distance are going to be different. The distance from the building is still going to be the area of that minus the area of that. The distance from the building is displacement. Right? Yeah, I was misreading this. Well, that's what I was doing at first. Distance from building is displacement. Total distance traveled is not. Total distance traveled is not distance from building. Distance from building is displacement. So I don't want the absolute value of that. I want the integral of that from 7 to 10. Which does give me minus 5. This might be the answer the more I think about it. Yeah. And that was, what was that number?
We got negative 265.
Now, let's think about that for a moment. Could that be the distance from the building? Well, we know that at 9 seconds, the distance from the building is 140. So let's plug in 9 seconds and see if this thing equals 140. So I think it does, because that's how I figured it out. Sure. Yeah, in other words, I used the 140 to come up with this thing. So that has to equal 140. So that function works, and now if I plug in 10 seconds, it should be a number less than 140. What happens when I plug in 10 seconds? I get minus 500 plus 900 minus 265, 765, that's 135. So at 10 seconds, she's gone back, or the squirrel has gone backwards by the area of that little triangle, which is 5 or 50. Why am I off by a factor of 10? I did my math wrong, didn't I? This says she went back 5 feet. 765, 900, she's 135 feet from the building at 10, at 10 seconds from 9 seconds. Should be the area of that triangle. Isn't the area of that triangle 50? No, it's 1 by 10. The area of that triangle is 5. So that's right.
Okay.
That expression right there is the correct expression for the distance from the building. And yeah, it was basically just integrating and solving for C.
Okay.
Is that all we got tonight?
No.
You sent them
Yeah,
in?
more.
You sent them
Yeah,
in?
I think I sent the next page on.
Okay. Yeah, I got it here. Water flows into a tank at that gallons per minute with T in minutes. If the tank held 500 gallons when T equaled 4, how much water in gallons was in the tank when T equaled 3? This is again integral as net change. So if we integrate this function, that's 6t squared
Yep.
plus 1. If the tank held 500 gallons at 4, so from 0 to 4, that thing equals 500. Because if it flows at that function for that time period, then the total amount of water that flows into the tank is going to be this expression.
Okay.
They didn't say it was empty to begin with, but can we assume that? I guess we can figure it out if we get the right answer. Huh? So let's solve this for, hold on a second. How much water was in the tank? This might, no, this we can't assume that it's empty. This isn't equal to 500. This is, we can figure out what this is equal to. Let's integrate it. What's the antiderivative of this?
It would be 12t.
Remember, we're going the other. We're integrating. Always start by adding 1 to your exponent and dividing.
Oh yeah, so it'd be 2t cubed.
Plus t.
We've been working on derivatives all day, so I've been.
I know. No, everybody does it. The problem is that when you get into integral calculus, you're still doing differential calculus half the time.
Mm-hmm.
In other words, you haven't gone through figuring out all the methods to do integration yet, but almost all of them involve a lot of differentiation. So you need to kind of get used to doing both at the same time. So let's see, what do we got here? We got 2 times 64, that's 128, plus 4. So we know that 132 gallons flowed into the tank in the first 4 seconds. So if it held 500 gallons and at the end of 4 seconds, it must have started with 368. So do we even need that? No, we don't. Or maybe we do. Let's see. Yeah, because now, if we know it started with 368, then let's just integrate this from 0 to 3. That's the amount that flowed in at the end of 3 seconds. We know 132 flowed in at 4 seconds. So how much flowed in at 3 seconds? We got 2 times 27, 54 plus 3. So 57 gallons flowed in the first 3 seconds. And it started with 368, so that adds to 425. Might be a 1 step less process to get that. I'm not sure how, though. I don't want to integrate from 3 to 4, because all that'll tell me is how much additional flowed in, which won't answer the question. So I really might have to do it this way, including figuring out what it started with. We've got that interference again. Sounds like
I can hear it.
sounds like a bunch of old ladies chatting on the phone. Particle travels v of t equals 6 cosine of t over 4. If the particle starts at x equals 1 when t equals 0, then its position t equals 6 pi is, well, if it started at 1, then its position is going to be 1 plus the displacement from 0 to 6 pi of the function. Since that's its velocity function, its total displacement is going to be the integral of that, and we're merely going to add that displacement to its starting position of 1. So, how do we integrate this?
We pull out the 6,
Okay.
and then it'd be negative sine of, it'd be positive sine.
Divided by the coefficient, which is 1/4, which means multiplied by 4. Take the derivative of that.
The derivative of sine is, it's the same thing. It's
Right, but in other words,
cosine.
the way you check your integration is by taking the derivative of that and making sure we get this. Well, let's take the derivative of that. We got 4 cosine of t over 4 times the derivative of the inside, which is 1/4, which cancels out with the 4, and we got what we started with. Okay? So, that's our antiderivative times 6, 24, and we're evaluating it from 0 to 6 pi. So the 24 times the sine of 3 pi over 2 when I substitute 6 pi for t. What is the sign of 3 pi over 2?
Is it -1?
Uh-huh. So this all becomes negative 24. When I plug in 0, I get 0. So I got 1 plus a negative 24, or minus 23.
All right.
Okay. And there's a lot of back and forth going on there, obviously. In other words, it's not one direction. When we're on the cosine curve, and we're going from 0 to 6 pi. So there's a lot of positive velocity, a lot of negative velocity, a lot of positive velocity. The distance traveled, not the displacement, on the next question. So, one way, if you could use a calculator, would be this. And the nth function does allow for absolute value. From where to when? I don't see that last number. From 0 to what?
6.
That would give you the answer right there. However, since we know this function is a quadratic with, what is it? It's t minus 5 times t plus 1. So it's a parabola. What did I say? T minus 5. So 5 is the intercept and minus 1 is the intercept. So this thing looks like this. So if we have to do it by hand, we have to do it in pieces. From 0 to 6. So what do we want to do? We want to take the positive area of this integral from 0 to this point and add it to the positive area. Well, this area is going to come out negative. This area is going to come out positive. Well, when this area comes out negative, we're going to take the absolute value of that. So let's do it. Since we know it goes from 0 to 5 of t squared minus 4t minus 5, that's going to be negative, so we're going to take the negative of it. That's going to give me the positive area of this section right here, which is going to be total distance traveled. Then I'm going to add to it the positive area from 5 to 6 of the same function. So let's see if we get 110 thirds. Now let's see, we got t cubed over 3, that's a good sign. Minus 4t squared over 2 minus 5t. This whole thing, the only thing you got to be really careful about here is your signs. Let's evaluate that expression at 5, because that'll give us the answer to 2 of them. So what do we have? We have 125 over 3 minus 50 minus 25. Oh, my goodness. So that's minus 75. So that's 125 thirds minus 225 thirds. That is minus 100 thirds. And I want the absolute value of that. So that's the distance it travels from 0 to 5 seconds.
Mm-hmm.
And I know so that is my evaluation at 5. So all I have to do is evaluate it at 6, subtract this, and I'll have the distance it travels from 5 to 6 seconds. So this is 216 thirds minus 72 minus 30. So that's minus 112. So we have 216 thirds minus 336 thirds. That is minus 120 thirds. And I've got, so that's the evaluation at 6 minus 120 thirds. And then I have to subtract the evaluation at 5, which is minus a minus 100 thirds. So that's a plus. 110 thirds. How did she get 110 thirds here? We got 100 thirds in the first 5 seconds. So going from 5 to 6 must be where I'm screwing up. At 120 thirds minus 100 thirds, that's only 20 thirds. That's not going to give me the right answer either. You see the concept that I'm doing?
Yeah. Should 120 over 3 be positive, and then the 110 over 3 be negative? Maybe those got switched, because now it would add up to 10 over 3, and then we just add those two together, and that would be 110 over 3.
Yeah, the only thing, it should be positive going from 5 to 6, because it's this part of the curve, which is above the x-axis. So how can I get a negative number here? Oh, I evaluated it at 6. When I evaluated it at 6, I got minus 120 thirds. And I have to subtract the evaluation at 5. And when I evaluated it at 5, I had minus 100 thirds.
And still wouldn't that be...
So when I add those two together, I get minus 20 thirds. Wow, which is negative. How can that be?
Because we got, I don't know. For the first part, we got positive 100.
Well, actually we really got minus. I turned it into a positive because it was minus a minus. In other words, this minus sign I put on it was because the curve was under the x-axis. That's the only reason.
Uh-huh.
And when you evaluate this function at 5, you do get minus 100 thirds.
Wow.
Or do you? Yeah, 125. 3 times 75 is 225. 125 is 5 cubed. That's minus 100. So the first one's minus 100 thirds. Second one, I get minus 20 thirds, which would make the total distance 120 thirds. Her answer says 110 thirds without a sign, but that's okay. She's asking about distance traveled. It's not a vector, so we don't need a sign. But why am I getting 120 and she's getting 110? I'm doing something wrong in my evaluation of this part. This part here must be 10, not 20 thirds. It must be 10 thirds. In fact, it would have to be minus 10 thirds, which is another puzzler. Because that quadratic, does that quadratic not this? It gives me a middle term of minus 4t. Gives me a, yeah, that's that quadratic. That's in x-intercept format. Ah, I got everything. I got the picture wrong. No, that means that the x-intercepts are at 5 and negative 1, which is where I drew it. But they wanted it from 0 to 6. So this part's negative. How come that part's not positive? I don't understand. How can that not be a positive number when I evaluate this thing from 6 to 5? It has to be a positive number. 6 is 206 cubed. Is that 216? Yeah, 36 times 6 is 216. So 216 thirds minus 2 times 36, which is 72, minus 30. So the top, it's 102, not 112. It's 102, which means it's 306, which means it is not 120, but 110. Minus a minus 100 over 3, it does travel minus 10 thirds. Added to my minus 100 thirds, we get the 110 third answer properly. I don't quite get why that comes out to be a negative distance traveled, but we do get the answer your teacher got. I just made an arithmetic mistake the first time through. I'm not sure why they both are negative. I don't know why it goes negative. Oh, yeah, it went 100 minus 100 thirds from 0 to 5, and it went minus 10 thirds from 5 to 6.
Yeah.
I don't get it. I don't get it, but I don't get a lot of things, so won't be the first time. Okay. Got another one?
Mm-hmm.
Starting at the top?
Yep.
There's y equal 2 square root of x. And there is y equal x. So we're going to rotate it about the line x equal minus 2. So this area here, it's like rotating it around the y-axis, only it's rotating it about the line x equal minus 2 instead of x equals 0.
Mm-hmm.
So what are we going to use? Discs or washers? And which axis are we going to integrate along?
Washers and then the x.
The y-axis.
Oh, yeah.
In other words, when we finish, gosh, I'm a terrible artist, but when we finish this rotation, we're going to have an object that looks something like that. And we are going to make it up with washers with holes in them right there. Since the skinny part, or since the washer is perpendicular to the y-axis, the skinny part is dy.
Mm-hmm.
So we're going to integrate from zero to there along the y-axis. Well, where are these two equal? X equal, well, let's first of all write it as a function of y. In other words, over here we have x equals y squared over 4. So now, to find out what the y intersection point is, I set y squared over 4 equal y. Y squared over 4 minus y equals 0. Y times y over 4 minus 1 equals 0. So this point is 0. We knew that. That's one intersection point. And the other intersection point is 4. Solving this for 0. Y over 4 minus 1, setting that equal to 0, gives me y of 4. So now I'm going to integrate from 0 to 4 dy. It's pi is on the outside. The area of each disk is pi times big R squared minus little r squared. What's big R squared?
It would be just y equals x. Or x equals y.
There's big R squared, y squared. Remember, we have to have a function of y.
Mm-hmm.
Minus, there's the curved part, so y squared over 4 squared. So let's see, we have pi times y cubed over 3 minus, this would be y to the 4th over 16, which would evaluate to y to the 5th over 80. And I'm going to evaluate that from 0 to 4.
Mm-hmm.
So I have 64 thirds minus, oh my God, what is 4 to the 5th? 64 times 16. You got a calculator handy?
Yeah.
Let me write it. Let me write it as that. It might factor because there's an 80 under it. So that times pi is our answer. Well, I can certainly do that. So now I have 64/3 minus 64/5. How unusual is that? Times pi. What's our answer? 96/5 pi. Well, could that possibly be 96/5? Maybe. Got to use a common denominator. So I have 5 320/15 minus 192/15. That is 128/15. Not divisible by 5 pi. That's the answer I got. What'd she get? She got 96 pi over 5. Ah! I did everything wrong. Sorry.
Yeah.
The big radius. Let's go back to the big radius. I forgot we were rotating at about the line x equal minus 2.
Oh, yeah.
Which makes the big radius what?
It'll be y squared minus plus 2.
Y plus 2 squared. In other words, the distance from here to here. If my washer's outside radius is this distance, and that is the y value, the x value plus 2. And the x value is y plus 2. We got to square it, and we got to subtract from it this value, which is y squared over 4 plus 2. Quantity squared. Since it's almost 9 o'clock, should we put that into a Wolfram Alpha? That's not going to be that easy to put into Wolfram Alpha, is it? Let's see what we got here. I'm 90% positive that this will give us the right answer. I don't mind doing the arithmetic here. Let's see. So we've got y squared, we got the integral from 0 to 4 of y squared plus 4y plus 4 minus, now let's square this thing. When we square that thing, what do we get? We get y to the 4th over 16 plus 2 times that, so that's just y squared plus 4. So we've got y squared plus 4y plus 4 minus, and if I remove the parentheses, it makes that a minus and that a minus. So this is what I have to integrate. The 4's cancel. The y squareds cancel. So I've got to integrate this. So that is 2y squared minus y to the 5th over 80. Again with the 80s. And I want to evaluate that from 0 to 4. So I only need to evaluate the 4 part. That's 32 minus, I don't like the way it's going already, 96 over 5. Okay, we might be able to come up with 96 over 5. Let's see, 4 to the 5th was 4 cubed was 64 times 16. That's 4 to the 5th. I am going from 0 to 4, yeah. Yeah, over 80. Perfect. This is going to do it. Because now that 16 becomes a 5. That's where I get my 5 in the denominator. This becomes 160 over 5. 160 minus 64 is 96 over 5 pi.
Ugh, it's not live arithmetic.
That's why they give you answers in calculus.
Yeah, seriously.
Because otherwise you wouldn't know that you'd made a little arithmetic error. And I guess we'll have to leave 5 and 6 for another time.
I got to turn this in tomorrow.
Okay. What do you want to do? You want to keep going?
Yeah, you could just charge the card, I guess. I got to finish this.
Yeah, no, we'll just do we'll probably do an hour-and-a-half session if we do the last 2 problems, and then I'll just make it an hour-and-a-half.
All right.
Yeah, I don't mind doing that. Who can resist the joys of calculus? Okay, so that's our function. L is tangent to the graph of f at x equal 3. Let S be the region bounded by the graph of f, the line L, and the x-axis. Find the area of that line. Okay. Yeah, that's easy enough. How do we come up with the equation of that line?
You take the derivative at the point.
Okay. So f prime of x is equal to 8x minus 3x squared. So that's the slope. At point 3, we have 24 minus 27. So that has, did I do that right? 3 squared is 9, times 3 is 27. So we have a slope of minus 3. Well, the point is what? If I plug in 3 for x, I get 4 times 9 minus 27. 36 minus 27 is 9. So that point is 3, 9. So we have a point, we have a slope, we can come up with the equation of that line. What did I say my slope was? Minus 3? So we've got y minus 9 equals minus 3 times x minus 3. Using point slope format. So now y is equal to minus 3x plus 9 plus another 9. So there's the equation of that line. To find the area under that curve, do I want to use vertical rectangles or horizontal rectangles?
It's like horizontal.
Yeah, horizontal is going to work much better.
And this is a calculated question.
Very good, because, let's think about this for a second. There's one problem with horizontal rectangles, and that is defining that first function as a function of y isn't so easy.
Mm-hmm.
I don't know how to do it. So let's think about this for a moment.
Maybe we could figure out where S crosses the x-axis.
That's the thing to do.
And integrate it.
Yeah, in other words, this function is going to look something like this. Yeah, we don't need to integrate along y. So that if you did the area, if we integrate with vertical rectangles, we're fine here. The only problem is here, it's going to take this function minus this function. So it's going to include the area down under here. So we do need to do this in pieces. We need to go from, yeah, all right, I know what we have here. So we're going to go from 3 if I factor an x out of that, I get what? What's this point here? If I let 0 equal x squared times 4 minus x, then x equal 4. So that point is 4.
Mm-hmm.
So to get the area of this part just there, I'm going to take this function minus this function. So I got minus 3x plus 18 minus, let's use parentheses, 4x squared minus x cubed. So that'll give me the area from 3 to 4.
Mm-hmm.
And I want to add to that the area from 4 to 6. That's 6. If I solve this, if I set y equal to 0 and solve this, the x-intercept is 6. So I'm going to go from 4 to 6 of this function, minus 3x plus 18 dx. Should we do that by hand or do it in the calculator?
I'll do that in the calculator.
Yeah. Why don't we leave that there? Make sure that I'm 90% sure that that's the right. That'll give you 7.917. Let's not spend our time doing the arithmetic. Let's look at this one first. Find the arc length arc length is going to be from 0 to pi over 4. the square root of 1, is it minus or plus? Plus.
Yeah.
dy dx squared dx. Right?
Uh-huh.
What is dy dx? If this is the function, oh, and let's see, there's a, what goes outside of this thing? Anything? What's the formula for arc length? Let me look it up.
I think it's just the square root of, I think that's what it is.
Yeah, I think that's what it is too. The trick here is figuring out dy dx. If, so...
Oh, wouldn't, to figure out dy dx, don't we just plug in x to
yeah, in other words, well, here's the thing. If f of x is equal to an integral, and the first part of the fundamental law of calculus says that if you take the derivative of that, if you take the derivative of an integral, you get this. Square root of secant squared of x minus 2. That's what the first derivative is. So that's dy dx. We want dy dx squared. So dy dx squared is going to be secant squared of x minus 2. So everything under the integral is now secant squared x minus 1. Oh, what is that? That's tangent squared. Square root of tangent squared is tangent. Integrating tangent of x is relatively easy. You have to use substitution. Oh, you can use your calculator. Right?
No, not on this one. It has an asterisk.
Okay. Let me show you how to do it. I'm going to use substitution. You've done integration by substitution?
Yeah.
Okay. Which one am I going to let be u?
Cosine? No.
No, you're right.
Oh, yeah.
It doesn't work if you let sine be u. And the reason is that if I let u be cosine, the derivative of u ends up in the denominator. Watch. Du dx equals minus sine of x, which makes du equal minus sine x dx. Well, that part right there, I can substitute for du. So now I'm going to turn it into an integral of u. Put the minus sign out there. I got du in the top, and I got u in the bottom, because cosine x equals u. Okay, well, what is this? That is the natural log of u. So the answer is minus the natural log of u, which is cosine x, evaluated from 0 to pi over 4. Well, the natural log of pi over 4 is root 2 over 2. So that would be minus natural log of root 2 over 2. There's our answer. Oh, and I got to subtract out the valuation at 0, which is just 1. And the natural log of 1 is 0. So the other half of that is 0. Now, she said, or this. Well, the reason is, you see why both of these are the same answers? Natural log of root 2 over 2 is the same as natural log of 1 over root 2. Or it's the same as the natural log of 2 to the minus 1/2. The natural log of 2 to the minus 1/2 is 1/2 the natural log of 2. So I can take my natural log of root 2 over 2 and turn it into this by just knowing that using log rules.
All right. And I did send you 2 more if we can shove them into another 15 minutes.
Okay. Didn't get it. Ah, there it is. You may have to help me read this one. I don't know. No, I can read it. Find the volume solid of a base is a circle bounded by, okay, that's a circle at origin at 1, that's the unit circle. And its cross sections are perpendicular to the x-axis and are equilateral triangles. Here's our equation. We're going to cover that with equilateral triangles perpendicular to the x-axis. Like that. Okay? So we're going to integrate along x. So we need a function of x. So the first thing we need to do is solve this for y.
You just do the square of 1 minus x squared, plus or minus.
The plus or minus, this upper half is the plus part, the lower half is the minus part. Okay? Well, the base of the equilateral triangle is twice this function. It's that. What is the area of an equilateral triangle?
It's just base times height, and the height is just the base times root 3.
There's actually a formula for it. I believe it's root 3 over 4 times s squared, which makes this easy because we're going to integrate from what to what?
From -1 to 1.
And the area of each of these triangles, so root 3 over 4 times the side, there's the side, squared, so that's 4 times 1 minus x squared. That should be relatively easy to evaluate. We can
Couldn't
also
do,
we can multiply it by 2 and go from 0 to 1 also, which will make it a little bit easier. What were you going to say?
oh, yeah, yeah. Oh, I was thinking something different.
Let's see if this gives us the right answer. So we have square root of 3 over 2. We're going to go from 0 to 1. So we get 4x minus 4x cubed over 3 from 0 to 1. You know, that's 4 minus 4/3. That's 2 2/3, which is 8/3. So we're multiplying this by 8/3. 8 root 3 over 6, 4 root 3 over 3. Bingo.
mm-hmm. This isn't too bad.
Number of rats changes at a rate of that per month. Determine the rate of change of the rats over the first 6 months. Determine what? I don't have all the writing.
Determine the average rate of change.
Oh, the average rate of change. Okay. Well, average rate of change, what's the general formula for average rate of change?
It's going to be 1 over A minus B from A to B
From,
function.
yeah, it's 1 over B minus A
Oh.
of that function. From 0 to 6. So we have 1/6 from 0 to 6 of this function that we can actually use substitution on also. Notice what we look for when we look to use substitution to integrate. We look, you're always using substitute, well, not always, but usually when you're multiplying two different functions, okay? I'm going to let u equal this. And the derivative of this is 2t. That's going to take care of that t.
Mm-hmm.
In other words, let me go through it the complete hard way just because I want to make sure you understand. If I write something you don't get, tell me.
Mm-hmm.
You understand that part?
Yeah.
Okay, so let's figure out what dt is. dt is du over 2t. Now, I don't usually do this part, but it's important because it shows you that when I go to substitute for dt, I'm going to have a 2t in the denominator, which is beautiful. It gets rid of that inconvenient t there. So if I want to rewrite this, and I don't use those same limits, which I'll talk about in a moment. So I've got du over 2t. I still got that t there, and I got a u down there, a square root of u, like that. Now the t's cancel out. I can take the 1/2 out, make that 1/12. So now I have 1/12, the integral from 0 to 6 of u to the minus 1/2. Now, when you use substitution, you can't really evaluate it at these limits. I have to go back and change my limits. Since I let u equal t squared plus 1, I would have to figure out what u is. And I can do that. Yeah, it's square root of 37. So let's do that, especially since I see their answer here. They obviously evaluated this at the new limits. Well, if u equals t squared plus 1, well, when I'm going from 0, I'm really going from u of 1. And when I'm going to 6, u is 37. So now I can do it. So now I add 1, divide by the new, and evaluate it from 1 to 37. Well, that is 2 root 37 minus 2 all multiplied by this 1/12. That's the answer. In other words, these 2's cancel with the 12 to give me a 6 in the denominator.
All right. Well, thank you.
You good to go?
Yep, that was that. That gives me 12 extra points in my test.
Well, good.
12 extra percent, actually.
Good. Good. Very good. Yeah, I hope things are going better for you. You seem to be grasping it pretty good. All right, Matthew, I will talk to you next time.
All right. Thanks, you too.
Bye-bye.